Okay, we are back with another video. We're still in chapter 7, still looking at areas under the normal curve, and we have our standard equation that we use to calculate the z values. Okay, and we calculate z-scores that were on opposite sides of the mean, and then z-values that were on one side of the mean or the other to calculate the areas between those particular values. So now we're going to do something a little bit different, and we're going to label this, we're going to solve for x. Okay, and let's go through an example. And probably the best way to do this is to go ahead and reference one that's in the textbook. So if you look at page 228 of the text, a normal value has a mean of 50 and a standard deviation of 4. Determine the value below which 95% of the observations will occur. Again, this is number 23. So again, what we have here is we have a situation in which we know that the mean is equal to 50. Mean is equal to 50. We know that the standard deviation is equal to 4. Okay, and we want to find a value below which 95% of the observations will occur. So essentially what we want to do, and I'm going to go ahead and switch this over to a new page. Okay, and we know that we've got a mean of 50. And that the standard deviation is equal to 4. But we want to find a value, excuse me, below which 95% of the values will occur. And so essentially what we want to do is we want to find a value here that will create a situation whereby 95% of the observations fall below this, and that means that 5% would fall above this particular value. Okay, and we can do that by going to our same z equation. And let's go ahead and we'll do that on another page. Z equals x minus mu over the standard deviation. And again, what we want to do is we want to find a z value that will give us a 95%, 5% split. So what we're going to need to do is we're going to go to our z chart and find the gap between the larger portion and the smaller portion to be 95 and 5. Okay, and I'm here on the second page. Hopefully you can see this okay. At 1.64, you see the breakdown between the larger portion and the smaller portion to be 0.0505 and 0.9495. Okay, that may be a little blurry. If it is, go ahead and take a look at your z distribution. At 1.65, we've got a breakdown between 0.0495 and 0.9505. Okay, so what we want to do is, in this case, we're going to split the difference because we want to find a 595 split, and the value that's going to come close to that is going to be 1.645. And I say that because that is exactly between 1.64 and 1.65. So we're going to go ahead, that's going to be 1.645 is going to be equal to our x value that we're looking for minus the mean. And here we said that the mean was 50 with the standard deviation of 4. From here, it's going to be very simple. We're going to cross multiply. X minus 50 equals 4 times 1.645. That is equal to 6.58. So x, to clear off this negative 50, we've got to put a positive 50 over here. So it's going to be 56.58. And again, this is very simple. This is how we solve for x. Okay, let's go ahead and do one more on the same page. Let's look at number 24. A normal distribution has a mean of 80 and a standard deviation of 14. Determine the value above which 80% of the values will occur. Okay, so this one's going to be a little different because now we want to find a value above which 80% of the values will occur, which means that 20% will be below this value. Now, so we're going to use the same equation. Okay, we want to find a z-value that gives us an 80-20 split. So when we look at our z-values, we want to find that 80-20 split. If it's not in the middle, you can find the one that's closest. If you go to, we're looking for 80-20, again, that's going to be the gap between the larger portion and the smaller portion. Okay, so at 0.84, we see a 0.2005, 0.7995. That is the split that's the closest to the 80-20. Okay, so that's going to suffice for our purposes. So the z value is going to be 0.84 equals x, and we said that the mean here was 80 and a standard deviation of 14. Okay, there's one thing that's wrong here. Okay, because this value is below the mean, this is going to be a negative associated z-value. And remember from your basic stats class that all z-values above the mean are positive, all z-values below the mean are negative. So this would have to be a negative value here. Okay, once again, we're going to cross multiply. X minus 80 equals 14 times negative 0.84. That is a negative 11.76. To clear out this negative 80, we add 80 over here, and then we get 68.24. So we would know that 80% of the values would be above 68.24, 20% of the values would be below that. So again, this is just a really short video showing how to solve for X.